Well, after the last video, hopefully we're a little familiar with how you add matrices. So now let's learn how to multiply matrices. And keep in mind, these are human-created definitions for matrix multiplication. We could have come up with completely different ways to multiply it, but I encourage you to learn this way because it will help you in math class. And we'll see later that there's actually a lot of applications that come out of this type of matrix multiplication. So let me think of two matrices. I'll do two by two matrices, and let's multiply them. Let's say, let me pick some random numbers. 2 minus 3, 7, and 5. And I'm going to multiply that matrix, or that table of numbers, times, let's see, 10 minus 8. Let me pick a good number here. 12, and then minus 2. So now, there might be a strong temptation. And in some ways, it's not even an illegitimate temptation to do the same thing with multiplication that we did with addition, to just multiply the corresponding terms. So you might be tempted to say, oh, well, this first term right here, the 1, 1 term, or in the first row and first column, is just going to be 2 times 10. And this term is going to be minus 3 times minus 8, and so forth. And that's how we added matrices, so maybe it's a natural extension to multiply matrices the same way. And that is that's legitimate. One could define it that way, but that's not the way it is in the real world. And the way in the real world, unfortunately, is more complex. But if you look at a bunch of examples, I think you'll get it, and you'll learn that it's actually fairly straightforward. So how do we do it? So this first term that's in the first row in its first column, it's equal to essentially this first row vector times this column vector. And what do I mean by that? Right? So it's getting its row information from the first matrices row, and it's getting its column information from the second matrices column. So how do I do that? If you're familiar with dot product, it's essentially the dot product of these two matrices. Or without saying that fancy, it's just this. It's 2 times 10. So 2, I'm going to write it small. 2 times 10 plus minus 3 times 12 plus minus 3 times 12. And that's all. I'm going to run out of space. And so what's this second term over here? Well, we're still in the first row of the product vector, but now we're in the second column, and we get our column information from here. So let me pick a good color. Nope. So this is slightly different shade of purple. So now this is going to be, I'll do that in another color, 2 times minus 8. So 2 times minus 8. Let me just write out the number. 2 times minus 8 is minus 16. Right? 2 times minus 8. Plus minus 3 times minus 2. What's minus 3 times minus 2? That is plus 6. Right? So plus 6. So that's in row 1, column 2. It's minus 16 plus 6. And then let's come down here. So now we're in the second row. So now we're getting our row information from the first matrix. I know this is confusing, and I feel bad for you right now. But we're going to do a bunch of examples, and I think it'll make sense. So this term, the bottom left term, is going to be this row times this column. So it's going to be 7 times 10. So 70 plus 7 times 10 plus 5 times 12 plus 60. 5 times 12. And then the bottom right term is going to be 7 times minus 8, which is what? Minus 56. 7 times minus 8 plus 5 times minus 2. So that's minus 10. So the final product is going to be 2 times 10 is 20 minus 36. So that's minus 16. Minus 16 plus 6, that's 10. 90, is that what I said? No, this is 70. 70 plus 60, that's 130. And then minus 56, right? That's what 7, minus 56, minus 10, so minus 66. So there you have it. We just multiplied this matrix times this matrix. Let me do another example. And I think it'll start. And actually, I'm going to squeeze it on this side so that we can write this side out a little bit more neatly. So let's take the matrix. Let's take the matrix. I don't know, 1, 2, 3, 4 times the matrix. I don't know, 5, 6, 7, 8. And then now we have much more space to work with, so this should come out neater. Okay, but I'm going to do the same thing. So let's first, so to get this term right here, the top left term, we're going to take, or the one that has row 1, column 1, we're going to take the row 1 information, edit, undo. We're going to take the row 1 information from here, and the column 1 information from here. So you can kind of view it as this row vector times this column vector. So it results 1 times 5 plus 2 times 7. 1 times 5 plus 2 times 7. Right? There you go. And so this term, it'll be this row vector times this column vector. Let me do that in a different color. So it'll be 1 times 6 plus 2 times 8. So let me write that down. So it's 1 times 6. So it's 1 times 6 plus 1 times 6 plus 2 times 8 plus 2 times 8. Now we go down to the second row. We get our row information from the first vector. So let me circle it with this color. And it is 3 times 5 plus 4 times 7. So it's 3 times 5 plus 4 times 7. And then we're in the bottom right. So we're in the bottom row and second column. Second row, second column. So we get our row information from here and our column information from here. So it's 3 times 6 plus 4 times 8. So 3 times 6 plus 4 times 8. And if we simplify, let's see, this is 5 plus, well, actually, let me just remind you where all of the numbers came from. So we have that green color, right? This 1 and this 2, that's this 1 and this 2, this 1 and this 2. Right? And notice these were in the first row and they're in the first row here. And this 5 and this 7, well, that's this 5, this 7, and this 5, and this 7. So interesting. In the first, this was in the column 1 in the second matrix, and this is in column 1 in the product matrix. And similarly, the 6 and the 8, that's this 6, this 8, and then it's used here, this 6 and this 8. And then finally we have this 3 and the 4 in the brown. So that's this 3, this 4, and this 3 and this 4. And then we can, of course, simplify all of them. This was 1 times 5 plus 2 times 7. So that's 5 plus 14. So this is 19. 19. This is 1 times 6 plus 2 times 8. So that's 6 plus 16. So that's 22. This is 3 times 5 plus 4 times 7. So 15 plus 28. That's 38, 43, if my math is correct. And then we have 3 times 6 plus 4 times 8. So that's 18 plus 4 times 8. 18 plus 32. That's 50. So now let me ask you, so the product matrix, if just write it neatly, is 19, 22, 43, and 50. So now let me ask you a question. When we did matrix addition, we learned that if I had two matrices, it didn't matter what order we added them in. So if we said A plus B, and these are matrices, that's why I'm making them all bold. We said that this is the same thing as B plus A, based on how we defined matrix addition, B plus A. So now let me ask you a question. Is multiplying two matrices, is A, B, that just means we're multiplying A and B, is that the same thing as B, A? Does it matter? Does the order of the matrix multiplication matter? And so I'll tell you right now, it actually matters a tremendous amount. And actually, there are certain matrices that you can add in one direction that you can't add in the other, or that you can multiply in one way that you can't multiply in the other order. And well, I'll show you that in an example. But just to show that this isn't even equal for most matrices, I encourage you to multiply these two matrices in the other order. And actually, let me do that. Let me do that really fast, just to prove the point to you. So let me delete all this top part. Let me see. Let me delete all of it. And actually, I can delete this. So hopefully you know, when I multiplied this matrix times this matrix, I got this. So let me switch the order, and I'll do it fairly fast, just so as to not bore you. So let me switch the order of the matrix multiplication. This is good because this is another example. So I'm going to multiply this matrix 5, 6, 7, 8 times this matrix, and I just switched the order. And we're testing to see whether order matters. 1, 2, 3, 4. Let's do it. And I won't do all the colors and everything. I'll just do it systematically. I think you just have to see a lot of examples here. So this first term gets its row information from the first matrix, column information from the second matrix. So it's 5 times 1 plus 6 times 3. So it's 5 times 1. Let me just write, actually, edit. I'm going to skip a step here. Edit, undo. Okay, so it's 5 times 1. So it's 5 plus 6 times 3 plus 18. What's the second term here? It's going to be 5 times 2 plus 6 times 4. So 5 times 2 is 10 plus 6 times 4. 6 times 4 is 24. Right? And all we did is took this row times this column right here. Okay, now we're down here for the set. So when we're doing this row, this element right here, the bottom left is going to use this row and this column. So this is 7 times 1, 7 times 1 plus 8 times 3. 8 times 3 is 24. And then finally, to get this element, we're essentially multiplying this row times this column. So it's 7 times 2. 7 times 2 is 14. Plus 7 times 2 plus 8 times 4 plus 32. So this is equal to 5 plus 18 is what, 23, 34. What's 7 plus 24? That's 31, 31, 46. So notice, if we call, let's say that this is matrix A, this is matrix A, and this is matrix B, right? In the last example, we showed that A times B is equal to 19, 22, 43, 50. And we just showed that, well, if you reverse the order, B times A is actually this completely different matrix. So the order in which you multiply matrices completely matters. So I'm running out of time. In the next video, I'm going to talk a little bit more about the types of matrix. Well, one, we know that order matters. And in the next video, I'll show that what type of matrices can be multiplied by each other. When we added or subtracted matrices, we just said, well, they have to have the same dimensions because you're adding or subtracting corresponding terms. But as we see with multiplication, it's a little bit different. And we'll do that in the next video.